Jai Hind to all. I am Shivpratap Singh, Assistant Professor, Department of Computer Science and Engineering, Akgec Engineering College. Today, the topic of discussion in data structure is graph, a non-linear data structure graph. So, we will discuss the core concepts or basics of graph. So, what is graph? A graph is a non-linear data structure consisting of vertices and edges. The vertices are sometimes also referred to as nodes, and the edges, so vertices are sometimes referred as nodes, and the edges are lines or arcs that connects any two nodes in the graph. Or formally we can say a graph is composed of a set of vertices and a set of edges, and the graph is denoted as GVA. A graph is a collection of vertices and edges. So, graph is a collection of or set of edges and vertices. And components of graph: vertices and edges. Vertices are the fundamental units of the graph. Sometimes vertices are also known as vertex or nodes, and every node can be labeled or unlabeled. So, node can be labeled or unlabeled. And edges are drawn or used to connect two nodes of the graph. It can be ordered pair of nodes in a directed graph. Edges can connect any two nodes in any possible way. So, there are no rules to connect any two vertices with the help of edges. Sometimes edges are also known as arcs, 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 and every edge can be labeled or unlabeled. So, edges can be labeled or unlabeled, depends upon the requirement or the specification of graph. A real world problem can be noted with the help of graph, a non-linear data structure. Before this, we already discussed about the tree. So, tree is also a part of graph or a restricted or graph. So, we can say so, graph can be defined as a set of vertices and edges, V set of vertices, and E is a set of edges, E1, E2, E3, E4, En. So, here we have a graph in which these all are the nodes, and the connection between these nodes are with help of edges. So, this is a edge, 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 edge. So, there can be multiple incoming or outgoing edges from a node. If a graph is a labeled graph. Here we have a undirected graph, no direction of edges. So, it is a undirected graph, no direction of edges. It is an example of a directed graph. Here there is a direction from row number 8 to 9, the flow of direction from F to G, F to B, from E to D. So, it is called a directed graph. Then we have a weighted graph also. So, a weighted graph consists of weights in edges called a weighted graph. So, we have these three types of graph: undirected, no direction, no weights; directed graph, direction of edges; and a weighted graph. There can be many other possible types of graph we will discuss later. So, these are the common categories of graphs. Next, we will discuss about types of graph, how many types of graphs we have. First category is a null graph. A null graph or a graph is known as a null graph if there are no edges in the graph. If there is no edges in the graph, we can say like this, or we can say 2 alone, or we can say, so this is an example of a null graph. No edges is called a null graph. Then second category of graph is a trivial graph. A graph having only a single vertex. It is also known as the smallest graph possible. Or single. Yep, this is called trivial graph. A graph having only a single vertex. Suppose we have a single vertex 1 in a graph. So this is called a trivial graph. So it is an example of a trivial graph. So we can say that this is a trivial graph because it contains only a single edge 1. Now undirected graph, third category or third types of graph, undirected graph. A graph in which edges do not have any direction. Edges do not have any direction. That is, the nodes are unordered pairs in the definition of every edge. So unordered pair of edges is called a undirected graph. We already discussed in our previous slide what are the undirected graph, where there is no direction between edges, is called undirected graph. Now fourth one is our directed graph, a graph in which edges have direction. That is, the nodes are ordered pairs and the definition of every edges are called directed graph, or we have direction of the edges is called directed graph. Then we have a connected graph. What is called a connected graph? The graph in which from one node we can visit any another node in the graph is known as a connected graph. Graph in which from a single node we can visit all other nodes. We can say it is a connected graph. Like we can have like this 1, 2, 3, 4. So we can say this is a connected graph. From any one node, we can visit any other node in the graph. We can say it is a connected graph. Next, we have a disconnected graph, a graph in which at least one node is not reachable from a node is known as a disconnected graph. Suppose we have this graph, or we can say if we have another categories of connections like this, in which these two nodes are disconnected from these two nodes. So it is called a disconnected graph. So it is a disconnected graph. One node, at least one node is not reachable, is called a disconnected graph. Then we have a regular graph. The graph in which the degree of every vertex is equal to k, and k is called the k regular graph. So degree of every vertex is k. Like we can say, like in the same example, we can say this connected graph is a regular graph, because if we can say regular graph, so in this graph, this vertex is having degree 2, this vertex is having degree 2, this vertex is having degree 2, means from each and every vertex, number of connected edges are called the degree of the particular vertex. So each vertex is having a degree k. So we can say k a regular graph. So this graph, or we can say this graph, it is also a regular graph. To a regular graph. So degree of every vertex is 2. So regular graph. Then we have a complete graph, the graph in which from each node there is an edge to each other node. From like the same example, we have these 4 vertices connected in the same previous example. So if we want a complete graph, or we can say how we can make a complete graph from this set of vertices. So we can say the graph in which from each node there is an edge to each other node. So there is no edge from 1 to 4 and there is no edge from 2 to 3 in this graph. So if we connect 1 to 4 and 2 to 3, so there is a directed or direct edge from any node to any other node. So graph with n vertices, has n into n minus 2, n minus 1 by 2, and into n minus 1 by 2 edges. We don't have to calculate the number of edges in a complete graph. So this is a formula of a complete graph. Complete graph with n vertices. So here we have n vertices, 4 vertices. So we can say we have in a complete graph we have 4 into 4 minus 1, 3, 4 into 3 by 2, 6. So we can say we have 6 edges if a graph is a complete graph. So we can calculate these 1, 2, 3, 4, 5 and 6. So we have 6 number of edges in this complete graph. Next, cyclic graph, a graph in which the graph is a cycle in itself and the degree of each vertex is 2, like previous example. So the graph in which the graph is a cycle in itself, the degree of each vertex is 2. So cycle graph, or we can say a cyclic graph, a graph containing at least one cycle is known as a cyclic graph. So at least one cycle. So here we have a cycle. If we can say like in this graph, this is not a cyclic graph, and if I connect 2 to 3, so there is a cycle between 2, 3 and 4, so it's a cyclic graph. At least one cycle is known as a cyclic graph. There is a one cycle, or we can say here we have another cycle. So this is a cyclic graph. Next, we have a directed cyclic graph. A directed graph that does not contain any cycle is known as a directed cyclic graph, like if we say in this graph there is no cycle, there is no cycle, it is called a directed acyclic graph. Then we have bipartite graph, a graph in which vertex can be divided into two sets such that vertex in each set does not contain any edge between them. Like if we have like these, if we have a set of vertices u and v, suppose we have these two sets of u and v, and suppose here we have u1, u2, u3, u4, here we have v1, v2, v3. So there can be a connection between these. So we can say a bipartite graph, a graph in which vertex can be divided into two sets. So vertex can be divided into two sets such that vertex in each set does not contain any edge between them. So there is no edges between these set of vertices and these set of vertices, but these vertices are from different sets are connected with each other. It's called a bipartite graph. Last, we have a weighted graph, a graph in which the edges are already specified with weighted graph. And weights graphs can be further classified as a directed weighted graph or undirected weighted graphs. We can say, suppose this in here we assign weights like 20, 30, 40 and 50. So this graph can be a undirected weighted graph, and this graph, if we assign weights to edges, so we can say this is a directed weighted graph. So these all are the types of graphs. A simple or a basic concept, what is a tree and what is a graph, and why these are the difference between a tree and a graph. So trees and graph. Trees are the restricted type of graph, just with some more rules. Like in a tree, there is no cycle, but in a graph can contain a cycle. So every tree will always be a graph, but not all graphs will be tree. And linked list, trees and heaps are special cases of a graph. These are the special cases of graph. Next, we have a comparison between tree and graph. So there are a comparison or limitations of tree and linear data structures. So tree constants hierarchical relationship only. A tree model contains hierarchical structures where every node has single parents, and this restricts their application to problem where relationships are more complex, such as networking and peer-to-peer interactions. So there this tree applications fails. Also, no cycles. Tree contains no cycles, so tree does not contains or does not allow cycles, which are necessary in many real world scenarios like circular dependencies or transportation roles. So this is also a limitation of a tree. Then limitations of linear data structure like arrays, linked list and stacks are one dimensional and sequential, and they cannot represent complex relationships like interconnections between multiple nodes, and this limits the modeling dynamics, multidimensional problems like social networkings, transportation system and dependency graph. So these are the limitations why we are choosing graph over these linear data structures like linked list, arrays, or over a tree. So these are the limitations of these. And why graphs are needed? So these are the necessities why graphs are needed. For modeling complex relationship, we can maintain complex relationships like many to many relationships. Cyclic relationships, graph allows cycles and enables the modeling of systems with feedback loops. Unrestricted connectivity, nodes in a graph can have any number of connections or edges, making them suitable for representing networks like transportation networks, train networks, airline networks, internet connections. These all networks are connected without any restrictions. Weighted relationship, graph edges can have weights to represent cost, distance or time. Like we can find out the shortest path problems, like finding the shortest route on a map. We use this in our daily life, shortest path, or using Google Maps to get a path from a source to a destination. So we can do this with the help of weighted relationships where weights are decided from I myself as a source to the destination as a second node. We can connect with the weight. Weight can be a time or distance. So these applications are possible with the help of graph. Directionality. So graphs can be directed or undirected, offering flexibility to model both one-way and two-way relationship, and dynamic and non-hierarchical structures. So these are the areas where we need graphs. Thank you.